In 2012, we started out, with the GeoNet monitoring system, our monitoring team noticed some earthquakes under this area, under the lake and under the mountain, and we were a little bit concerned that might be magma moving around. We raised the volcanic alert level from 0 to 1 for Tongariro. I started working on a volcano hazard map, and then a couple of weeks later, we had an eruption. And as far as volcanic eruptions go, it was actually really tiny, but it was still very dramatic. It went kilometers into the air. It was in the middle of the night, and actually one of the first indications something had happened were phone calls in from local iwi who live on the other side of this lake, who had heard something and then could see something in the middle of the night. It was a nice clear night, and actually an eruption column went up of ash and steam. You had surges, a type of pyroclastic density current, spreading out quite a long way, about half of what you can see of the width of the mountain there in each direction. And you actually had a landslide happen from the deformation right at the vent, and you got a little lahar down into a creek there, and actually blocked it up for a bit, and we were a bit worried about a lake forming and a failure there. So quite a few different processes, quite a few different hazards from this. The ash blew all the way to Napier. Now it didn't leave much of a layer beyond about the desert road, about 10-15 kilometers this way, but actually the air quality meters all the way on Napier picked up a little spike. The really fine ash was blowing all the way to Napier. Really dramatic eruption. It kind of died away and was just steaming for a while. The tracks were closed for months, and then again 2 or 3 months later we had another little eruption. A geothermal system had kind of established itself in the vent, and it's just that had an even smaller explosion again, kind of late in the winter going into spring. But again, these ones wouldn't even be preserved in the geological record. They must happen all the time, but the stuff that actually makes up the mountain are much bigger eruptions over a much longer time period. And as geologists, they're what we tend to focus on, and we don't even have a record of these little guys. Yeah,
it's really cool, and there's a nice little University of Canterbury connection in there, because it was a great lesson that New Zealand Inc. we all worked together on some of the hazards, right? And,
yeah, definitely.
And we had a student that me and Graham both worked with who was mapping where the ballistics went. So the rocks, chunks of the volcano were thrown out. Some went through the roofs of a hut.
There used to be a hut, yeah. So there used to be a hut to the right, actually. There's another hot spring that's been there for a very long time. Ketatahi, you can see the steam just below the snow at the right. There was a hut near that got damaged by ballistics this big, thrown more than a kilometre, about 1.5 kilometres over to that hut. They went through the roof, they busted up the Tongariro crossing track, and this PhD student, Rebecca Fitzgerald, her work is going to be very helpful in us calculating where those ballistics might fly and making hazard maps of where the limit of safety might be decided to be on future hazard maps for future eruptions.